So I'm here to talk you through IDL code generation within Chat GPT. This is a two-phase process whereby the first phase is to generate candidate functions, which will then be fed into the IDL creation. That IDL itself will ultimately form an interface as a contract system whereby the LLMs can refer to it, look at the types, the function definitions, the return types, and always have a ground truth as to what has been generated, what hasn't been generated, what functions are available, and ultimately it allows you to generate systems that expand beyond the typical context window in a traditional LLM chat. The secret sauce in this is that the code that's generated will be running within the Python execution environment within ChatGPT itself. Ergo, even if the implementation details are lost to the LLM's context, it always knows that that function is available, the inputs that that function takes, and the outputs that are expected from that function. So I have a IDL template here, which is basically just something that I use to provide to the LLM, which will allow the LLM to populate with the necessary functions, return types, and data types, for example. So with all that being said, let's go on to this process. So I'm trying to think of a use case that we can sort of demonstrate here. So what I'll probably do is I'll pick something like a hospital patient management system. So let's just dive straight into a chat with ChatGPT here. So first thing I'm going to do is I'm going to try and establish all the candidate functions we might need in the system. So this is traditionally just an ideation phase with ChatGPT. So without further ado, I'm going to ask ChatGPT what functions we may need for a hospital patient management system. Okay, so you can see it's coming up with some things here. Okay, so that's fine. Now what I'm going to basically do is ask the system to generate essentially a set of function names and modules to encapsulate all those different sections. So what I'm going to do here is just sort of proceed and ask the LLM to generate a set of functions and modules. So I've basically asked it to generate module names and functions names that encapsulate all of the above, and to use snake case purely because we're using Python here. So here we go. So here's some things that have been thrown up: patient administration, register, update patient demographics, assign medical record numbers, consent forms, admit patient, discharge. There's some scheduling, there's some clinical documentation, pharmacy medication management, billing insurance, reporting analytics, security management. So yeah, so all this good stuff. Now obviously I'm not overly familiar with this domain area myself, but obviously we're sort of just ideating here with ChatGPT. So what I'm going to do is I'm going to ask ChatGPT to further populate and further enhance the candidate functions. Oh, that's a unfortunate spelling there. So here we are, so we're just basically demanding a bit more from sort of Chat GPT here. Now I'm not happy that it's basically split these into sort of separate PY files, so I'm going to ask that it just use module names and not the .py. Okay, that looks a decent haul we've got here, so fabulous. Okay, so now we've got that, what I'm going to basically do is I'm going to give this LLM my IDL template and have it populate phase 1, which is ultimately the IDL contract. So this is pre-code generation. We're just going to provide this template and we're going to have it generate all those functions. Copy that. Let's go in here. Populate phase 1 of our IDL with all of the modules and functions we have identified. Okay, let's get trucking. Just going to scroll up here and make sure that there's nothing, everything has been implemented. Can you cross check? Okay, so that's all 130 endpoints and 12 modules. Now I'm going to make sure that it sticks with the IDL template. So obviously the LLM took some liberties there and broke away from our template structure, so we're going to try and bring this back in line. This looks more like it. Oh yeah, this is what we're looking for. So we'll see. We can obviously see it's been a bit lazy here, so we're going to demand that it leaves nothing out. This is my first time playing with the new O4 Mini High, so I'm sort of no doubt going to possibly not be tickling it the right way, but let's see how it goes. So you can see this is becoming much more robust, much more contractual, let's say. There's a big problem people have with LLMs is hallucinations. This is one method to allow you to generate systems that are larger than context, whilst keeping the LLM grounded on a source truth, because at any point you can always drop that IDL back into the conversation and have it become aware of the functions, particularly when things have already been pre-implemented. So as you go module by module, it's sometimes necessary to feed the IDL in again, but it doesn't cause any issues or any problems in that regard. Okay, now I'm going to just, for one final time, ask if everything has been implemented in terms of the IDL to the functions. Have all functions been comprehensively Okay, so that looks like we're finishing phase one. So now I'm going to start a new chat window and I'm going to basically feed this into the code generation IDL. So let's go for a new chat and we are going to use 4.0, which has the internal Python interpreter. Can you, within your Python environment, implement this IDL function by function. By function. After each function, after each module, we will have it ask if we wish to proceed. Now obviously we need some way of storing state, which is typically SQLite. So could you within your Python environment implement SQL IDL module by module, function by function, using SQLite as a database. Start by generating a database. So here we go. This should be the IDL. So we're obviously at phase 2 now, so we should be in the. We should now be able to feed this. Can you within your Python environment implement this IDL module by module, function by function using SQLite as a database? After each module, ask if you wish to proceed. Start by generating a database. So here goes. This is looking exactly like what we need. Okay, so again it's been a bit lazy here, but we can see we'll probably want all tables implemented. So this is the kind of flow we like, where we are asked if we wish to continue creating. So this is a good model whereby it's iterative, step by step by step. So when you find yourself asking please continue, it's generally a good sign that we have a good workflow with the LLM. So you can see it's a non-trivial system we're building here. Patient management, appointments, documentation, pharmacy, billing, claims, reporting analytics, alerts, notification, telehealth, inventory and equipment. So, it's a fairly large system now. So we're now going to implement the first module. So let's ask it to proceed. Please proceed and test. So here we are. So exactly what we're looking for. Registering patients. So you can see we've got an execution, first name, last name, date of birth. Obviously in the real world you'd probably review the IDL and see things that need to be added in, but obviously for brevity we've just sort of gone with it. I don't want to say vibe code, but we're certainly sort of running fast and loose a bit here. As we can see, we now have a patient added within the system. Patient administration service has been partially implemented and tested successful. What we've implemented. Would you like to proceed with the next batch of functions in the module, such as update patient demographics? Yes, of course we do. Continued success with the patient administration service, implemented and tested, contact details, partial match, normalised address, recorded research consent, revoked consent. So so we're all looking good. Continue with the next set of functions. Please proceed. Okay, so we have new implementations, admitted patients, discharged patients, transferred patients. We've got some events, and we've obviously a bed occupancy report. So we're all looking quite good. So now we're in appointment scheduling. So as you can see, we're looking not bad at all here. So let's proceed. Okay, now I'm actually going to go have a quick look at the IDL just to make sure that we're not missing anything from the second module. So let's scroll down here. Administration. Appointment scheduling, schedule outpatient, cancel appointment, list appointments, add to wait list, okay, remove from wait list, set appointment reminder, okay. proceed with the next set of appointment related functions? Indeed we do. So me just checking that the LLM is being honest here. Okay, let's crack on. This is all looking good. Clinical notes, updating clinical notes. We should see cough changing to cough and fever here. So let's check this out. I should see the output. Would you like to proceed with the next group of functions? Yep, indeed we do. Final set of functions, yeah, I think we do. So obviously in a traditional code generation system it's pretty much unheard of by probably many functions ago, we would have run into hallucinations and issues of context being lost, but because of the IDL, we're able to sort of just continually generate code and proceed because we have this ground truth. Okay, let's proceed. This is obviously in the pharmacy system now. Okay. So let's just have a quick look at this verify method. Create, modify, cancel, verify. So where order ID, medication, yep. Verify that, yep, fair enough, that looks good. Okay, let's continue with the functions. There we go, so all functions for the pharmacy now implemented. Billing and insurance, yep, let's go. So yeah, so we're looking pretty good there. Yep, let's just proceed. just going to check how long we've been recording for here, as it feels like it's been going on for quite some time. I can't see the timeline, so I'm going to assume it's been 20 minutes or so. Anyway, I'm starting to get a bit bored here. But yeah, let's just proceed. As you can see, we're starting to come into the positions where some things are mocked. Okay, so now we're into security. It's possibly one of these things that, yeah, you're going to look at sort of actually implementing proper JWT. I'm going to actually ask it to give it a much more robust implementation. This is where we may actually start to unravel as functions get duplicate redefinitions. I just felt it was going a bit too down the route of mocking functionality, so I prefer to see things like SHA-256 even within the mocked system, so as opposed to just returning true. Okay. Yeah, so now we've got password hashing, salt. Yeah, that's much better. Yeah, let's just proceed with this next module. I have absolutely no idea what an HL7 message is. The purpose of this is purely just to demonstrate the size of systems that can be generated here by sort of underpinning it with the Python runtime. Okay, let's just proceed to the next module. Let's just have a quick look at this process alert queue. Yeah, that's looking good. Yeah, I'm getting a bit bored myself here, but obviously creating a fictional hospital and generating a full hospital management system is, yeah, obviously not the most exciting thing in the world. Let's proceed. I'm actually going to get these usage reports a bit more solidly implemented, so I'm going to ask for these two. So basically the two inventory, yeah, the inventory usage report I want implemented. I'm just about to have a coughing fit as well. Here we are. So this is the first error we've had within the Python runtime, and one of the benefits, obviously, of using the execution environment here is it's able to look back and actually fix its own issue. So as we can see, it's now corrected the code and fixed it. So yeah, so assignments, simulated usage, masks, yeah, they were all good here. So final module, yeah, let's go. Okay, so we can understand why it's mocked a lot of this stuff. So that's not a problem. The cross-cutting utility service. Okay, fair enough. Now what I'm going to do is I'm going to get to, now everything should be implemented, what I'm going to do is I'm just going to get it to give us um, a zip of the final implementation. Let's see if we can do that. First I'll get it to give us a dump of the database. Or not a dump, but a select star from all the tables. But just to prove that obviously the code that we've been generating has been running here, we should see at least some test data for obviously records that have not been deleted. So let's just give this a minute. Looks like we're going to time out here, but let's just give it a minute. Now we're looking good. Fair enough. Past medical, yeah, we're all looking great here. Peanuts, vital signs, yep, this is all lab order, medication, charges. Wait, it's tomorrow. Yep, 10 AM. This is all looking familiar. Portal accounts, yep. That was the gloves, yep. Yep. It's been so long ago, I sort of struggle to remember a lot of these. Just have a quick swatch of this. Yep. I'm going to have a quick search in the code just to find a reference for one of these. Supply assignment ID. That's everything. So let's see, supply assignment, supply. This is the supply assignment. So this looks like some code here where we should see entries amox 500 dos 875. Gloves, amox 500. Okay, quantity nickname. Should see gloves 480 somewhere. Gloves 500, assigned to patient 20, so we should see 480 for 480. Yep, there we go. Bum bum bum. Yeah, so obviously we've got the code's been generated, so obviously some things have been mocked, but all in all we've generated a fairly large system there without too much iteration or debugging. So ordinarily as I was generating, I'd be copying the code files off, or the code that was generated, into a sort of comprehensive file, but there is a trick where you can get the runtime to zip the code that's generated and allow you to download it. It doesn't work particularly well in large systems, but let's just give it a go. So obviously this is complete fictitious, as we've obviously been simulated organisation of module into files. Yeah, that's... Yep, I knew it would fall down there. Yeah, I think... Yep, I think that was one ask too many, but we're fine. But I think we'll call it a day.